Welcome back, Dr. Linder here. We are going to be looking at the microscopic part of a muscle now. And you're going to hear these terms epimysium, perimysium, and endomysium. And when you look at it, endo sounds like it's inside, and then peri will be in the middle, and then epi means above, it'll be all the way on the outside. I also want you to pay attention to the periosteum. This is a term that we covered when we did osteology. So the periosteum is the layer that covers bone, and you'll see that tendons are, it's this part here, and tendons are really just an extension of the muscle. So muscles are going to contract, and again, contraction means that they are generating tension. It will transmit that tension to the tendon. The tendon pulls on the bone, and the bone moves, creating movement. Fascia is a layer that surrounds muscle. It surrounds organs and it surrounds blood vessels, but fascia happens to be a problematic feature of muscle. Fascia is a problematic feature of muscle, and here's why it's problematic. If you ever seen anyone that has broken their arm or broke their clavicle, the arm is always like in a sling, right? If they break their clavicle, the arm's in a sling and the elbow is flexed. If they break their arm or their forearm, again, the arm is in a cast and the arm is flexed. And it's kept in this bent angle of 90 degrees. Think of what happens to these people when the arm isn't being used and there's no nerve impulses that are being delivered to those muscles. When muscles aren't used, they atrophy, right? They atrophy, they kind of break down a little bit. So one limb may appear to be thinner than the other just due to lack of use. It'll atrophy. When the cast is cut off, 5, 6, 7 weeks later, when the cast is cut off, the arm doesn't open up. It doesn't straighten out very easily. It takes a while to get it to open up, and that's due to fascia. Fascia is highly adaptive and responsive, and it kind of learns and adapts to the position that the muscle is in. So if a muscle is in a shortened position, the fascia is in a shortened position, and then the arm has a more challenging time to elongate. Okay. So that's when we have to do more manual medicine and physical therapy and massage therapy and chiropractic to try and work and open up the areas that are restricted. Okay, let's look at these terms here. We have these small muscle cells. These are called muscle fibers. And these muscle fibers are surrounded by a layer called an endomysium. Okay. When we have a bunch of these endomysiums grouped together, let's see if I could draw this for you like this. So let's say here is a muscle fiber, and here's a muscle fiber, and here's a muscle fiber. Now around each of these, there's an endomysium like this, okay? An endomysium. Here could be another one. Let's say here's another fiber and another fiber and another fiber, and now we have an endomysium around them. Okay. Now, a fascicle is when we group this together. That's a fascicle, and that's a fascicle. But the layer that makes up this fascicle here and here, that's a perimysium. That's this one here, a perimysium. So I'll put a P for perimysium. But this is also referred to as a fascicle. Okay, so you have two fascicles here. Now, if I surround these two fascicles and I group these together, this layer is called the epimysium. That's this one here. Okay, So they all come together, the endomysium, the perimysium, the epimysium, to form what we call that skeletal muscle. Okay, you see the same thing here. This is just a different cut where we have an endomysium, the innermost. When you get a bunch of those endomysiums together, making this, all of those, right, that's a fascicle. When you get a bunch of these fascicles grouped together, what's going to surround that is all of this going around, and that's the epimysium. Okay. This one here on the inside, that's the perimysium that's going around. The perimysium also makes the fascicle, just to review that, okay? And then all of them come together, right? Here's your endomysium, and then here's your perimysium, then here's your epimysium. They all come together to form the tendon. Tendon is going to attach to the periosteum of the bone. Okay, so we have skeletal muscles made of these individual cells called muscle fibers, and each muscle fiber is surrounded by an endomysium, a group of 10 to 100 muscle fibers surrounded by a perimysium, that's the muscle fascicle. Then when you get a bunch of those muscle fascicles, the layer that surrounds that is the epimysium, and then that will actually create the skeletal muscle. Now you can have fascia around that, remember? So you can have fascia that surrounds that. It actually surrounds everything. Muscles, it surrounds the organs, it surrounds blood vessels, and I explained the problem with fascia. And that's where you need that myofascial release that's done when muscles are in a shortened state. That means the fascia has adapted to it and it won't allow the muscle to elongate. Now remember, tendons, you have an endomysium, a perimysium, an epimysium that extend through the muscle. They join together at the end to form tendons. Tendons are the inelastic connective tissue fibers that attach to the periosteum of the bone. Muscles generate their contractile force or their tension. It transmits them to tendons, which are more inelastic, and allows them to pull on the bone to create movement. Whenever we see a broad, flat tendon, we call that an aponeurosis. And you'll see this term with a few muscles. You'll see it with the biceps tendon, the biceps brachii. The insertion is near the radial head, just a little bit distal to it. There's a radial tubercle there. But the insertion, they call it the bicipital aponeurosis, the bicipital aponeurosis. Another aponeurosis is with the lats, the latissimus dorsi. So the lats, let's say this is your sacrum, and then let's say that's one pelvic bone, and that's another pelvic bone, and you have your spine, and then you have your scapulas off to the side, right? And then you have your humerus and your humerus. The latissimus dorsi originates off of the lower six thoracic vertebrae and all the lumbar vertebrae. So it kind of goes like this, the lats. And it also goes from the sacrum and a little bit of the pelvis. So because it's going like this, it's a pretty wide muscle. It's a very, it's a very wide muscle. And it has a wide origin because it's the lower six thoracic vertebrae, all the lumbar vertebrae, the sacrum, the pelvis. Because it's such a wide origin, they call it the thoracolumbar aponeurosis. And that's for the latissimus dorsi, the thoracolumbar aponeurosis. Okay, when we come back, we're going to get into the neuromuscular junction.